right?
I'm sorry?
We can put a signal on a line.
Yeah, if you have,
Does it have to be cold? Can you put it on a live line?
No.
is to the best, I've never put one on a live
No,
conductor.
you'll blow that box right there.
That's what
If, here's, as we understand electrical circuits, if you put 2 wires down, I would say, no way, Jose.
No way, Jose.
But if you just connect 1 wire and you make sure that this one is isolated, it may work still. But you're not gonna do it with mine.
Okay. Alright.
Yeah, if you don't hook up both wires,
Good
you're not gonna tone it out. You gotta have both wires.
Yeah.
Well, if I have this wire connected here, and I have this on,
Oh,
so I'm
that's a
still
nice
putting
one,
out,
man. That's
I'm
good.
putting out a signal.
Hello?
Basically,
You put it on that extension cord right there.
My Mythbusters.
basically what we're doing here is this sends out a frequency hertz that can be picked up by this wand. If I have a circuit that is really far, like you guys have, and I have conduits that have 12 conductors inside, I need to determine which one's which. Maybe they're all red. I got 12 red wires starting here and end up over here. Well, I don't know which one's which. I can connect the toner to it, and I could try to locate it. And I'll be able to locate it. This one will also induce, it'll also put induction on other conductors. So sometimes if they're traveling for too far of a distance, you'll see that they all have that. You can hear the sound from all of them. But there's going to be one that's going to be louder, and that's going to be the right one. All right, so we've talked about amps. We've talked about meters. Let's apply what we know with Ohm's law to meters. We have a wire here, it's got 5 amps. And we have a neutral conductor. Got 5 amps going this way. We have our load over here. And our neutral conductor going out. We got amps going. Actually, let me put these a bit closer. There we go. Sometimes you're going to open up a box and you're going to find that the wires are really close together. I don't have much slack. Maybe they're zip tied together in a panel. I want to check my amps on this conductor going out to this load. I take my amp probe and I put them on both of these wires. How many amps am I going to see?
Nothing.
If I put on this wire, how many amps am I going to see?
5.
If I put on this wire, how many amps am I going to see?
Nothing.
If it's just a neutral,
Nothing.
amps go out to the load and they come back.
5.
So if I test them both, they'll say 0 because it's canceling out.
Oh.
If I do one, it's going to say 5. If I do the other one, it's going to say 5. What if I don't have 5, but I have somewhere between 0.3 and 0.5? The problem is with this meter, I can't check 0.3 and 0.5 amps very accurately. It's not accurate enough to be able to do that. So a possible solution for that is to,
Oh, put a coil in there or whatever?
if I put 10 wraps and connect it back up,
Okay, 10 times.
and I take this and I put that amp probe on there, it would be
10 times.
it'd be 10 times whatever this was. So if it was 0.3, it would say 3. If it was 0.5, it would say 5. So I can make a tool that's not very accurate.
They have those that you plug into the wall for your, it says 5 times and 10 times, right? For a plug-in appliances, you know, you haven't seen that? Oh, I had one once.
I'm not familiar with that. What was that for? To see how much current you're using on your?
Yeah, on like an appliance that didn't use much. You plugged in the appliance and you plugged in the wall, and then it had 2 coils on it.
What would be the purpose of that though?
It was 2 times or 10 times if you couldn't read it for a small appliance.
Oh, just so you could troubleshoot?
Yeah, just so you could read the low amps because I guess the meter wasn't accurate enough. It came with that.
Yeah. Yeah, the meters, sometimes you're gonna find although they're very helpful, sometimes they don't have the accuracy that you need that will be helpful for you. How much, since we talked a little bit about transformers, we talked a little bit about pretty much everything we use is DC. When we utilize electricity, we're using DC. When we change AC to DC, we use a transformer. To do that, we use it's just escaping my mind. Diodes, a rectifier. We use a rectifier to rectify the voltage to a straight line DC voltage. So when we do that, we step it down. Transformer, let me draw this a little bit bigger for you. So we have a transformer. Essentially, like I said before, we have a transformer. Let's say this has 100 windings. And then we have an iron coil, or iron core. And then we have 10 windings over here. So this is our primary. Power coming into a transformer is always considered primary. Power coming into a disconnect is always considered line. So power going into a transformer is primary. Power leaving the transformer is secondary. And then a disconnect would be disconnect to our breaker, or pretty much anything else would be line and load. Alright, so if we connect to a transformer, is this wire directly connected to this wire?
Yes.
If I take a continuity tester and I'm checking,
Yes. Well, it should be.
what if I have a transformer just sitting in this room, there's no wires connected at all? If I test from here to here, am I going to have continuity?
Yes.
What about from here to here?
Yes.
Because it's directly connected. We can see that there's no break in that coil. It's directly connected. So if we have a transformer, we have a wire going from here to here, we always have, if it's wired, we always have current traveling through the transformer. We always are using electricity. If the transformer is not sized correctly, if it's a 150 kVA transformer, it's just sitting there vibrating, using electricity, and it's not really accomplishing anything. And because that's the case, if I plug in my USB adapter to plug in my smartphone, I'm using electricity as long as that thing's plugged in. Everything in this room, including this TV, the TV's off, it's still using
Even when there's no
electricity.
load on there, is it the same amount?
It's not the same amount, it's
But it's
different.
still used, okay.
It's being used. So this TV is using electricity as it's off, because inside there it has a transformer, and it's utilizing electricity to make DC available. So when I push the remote control, the thing comes on. Virtually everything in this office is doing that same thing. They're all using electricity, even in the off position. So when you guys are out in the field, troubleshooting something, following the amps, looking for voltages, you need to make sure that you know that things are going to be using electricity even though it's not working. I got one more thing before I want to talk.